Okay, purifying copper. Now, copper is one of those amazing metals that we take for granted. It's everywhere around us, like in the cables that are leading to our devices right now, pipes, pans in the kitchen, and also in alloys, lots of different metals like doorknobs and in cars and etc. Or maybe not in cars. Would there be copper in cars? In the cables, I suppose. Um, but very little else. Anyway, I digress. Uh, in order to use many things in the world, we need to have the pure starting material. And also, impurities, especially in things like metals, can really affect the properties of that particular substance. So, the first thing we need to do is we need to purify copper. Now, copper is a relatively unreactive metal and can be found in some places in the world as an element. So actually, it can be found in its elemental form, a bit like gold and silver. But typically, it's found in ores, and we have to get it from the ores. Once we have some impure copper, we can use electrolysis to purify it. This is just a bit of an overview of the purification and simple rules to remember. The anode in this particular electrolysis, the anode is the impure copper. So we get a chunk of impure copper and make it the anode. How do we do that? We attach it to the positive side of this cell or battery, electricity source, and then the negative electrode, the cathode, is a little bit of pure copper, okay, that you've prepared beforehand. So anode impure, cathode a little bit of impure copper. Why do we only need a little bit? Well, the idea here is that the copper from the anode goes into solution and the copper from the solution is deposited on the cathode. Okay, so this could be copper 2 sulfate solution, which is blue, and this is a great way of purifying copper. Only the copper is deposited on the cathode. So let's look at the chemistry behind this. At the anode, typically at the anode, we'd get anions attracted there, and there'd be some kind of a reaction with the anions. The anions would lose electrons. But in this case, this is the classic example of electrodes not being passive but being active. So the anode here, because copper is so unreactive, the easiest thing for it to do is for it to go into solution. So the copper atoms become copper ions, Cu2 plus. So they go into solution at the anode. Okay, there's the equation. Obviously, that's a solid, and this would be aqueous because it's gone into solution. Okay, but simultaneously, and these electrons have been given up, the copper's gone into solution, the electrons go around the circuit, the electrons that the copper gives up. This cell is like a little electron pump. So it pumps the electrons around the circuit. They go to the cathode. This is negative. And at the cathode, the copper ions that are in solution, they gain those 2 electrons and become a copper atom. So this deposits on the copper cathode. Okay, that's the basic idea. The copper anode takes part in the reaction, so it's an active electrode here. And the anode, underneath it, the anode has a kind of mud or sludge. Just drops off as the copper goes into solution, it drops off, and this sludge is full of precious metals, such as platinum, silver, and perhaps other transition metal elements. Okay? Now we could show all of this is happening. We can do it in the lab by weighing the 2 electrodes before you start and then letting the electrolysis take place for 10-15 minutes, and then you weigh them again, and you'll find that the anode has lost mass and the cathode gains mass. Okay. Now let's have a little look at what would happen with exactly the same electrolysis with copper sulfate solution, but with inert electrodes. Okay, so this copper sulfate solution would still be blue. Okay, they haven't colored it in the diagram, but it would still be blue. But if we use graphite electrodes, there's a slight difference. Now, at the anode this time, the copper doesn't exist, so it can't go into solution. So the anions are attracted to the anode, the sulfate ions and the hydroxide ions, and you know the sulfate ions won't discharge, so the hydroxide ions discharge in that way. You would see colorless bubbles of gas, which would be oxygen. At the cathode, we do get the same reaction. The copper ions in solution, because copper, if you look back at your discharge series, copper will discharge before hydrogen ions. So copper ions discharge first, then you get a layer of copper formed on the cathode, same as before. Okay, so you'll see it's kind of like a pinky browny deposit on the cathode. Watch the video because it will give you a little bit more information about this process. This is an important final note, and that is, if we use copper electrodes, the blue color of the solution does not change. Okay, but if we use graphite electrodes, the solution slowly loses its blue color. Think about why for a second. So if we use copper electrodes, as the copper goes into solution, it comes out. So the amount of copper in solution is constant. So the blue color, which comes from the copper ions, is constant. If we use graphite electrodes, what happens is the color slowly disappears and it becomes colorless because the blue copper ions are deposited on the cathode and they're not replaced by the anode. So the color is slowly lost. Okay, read the pages and answer those questions.